A few days ago, I posted an unboxing video where I showed some of the key components that will be used to build a flight computer for my future rocket project. If you haven't seen that video yet, go check it out first. The link is in the description. Today, the journey continues. It's time to assemble those parts, run some tests, and start laying the foundation for something much bigger to come. I started by attaching header pins to the BMP-280 to make it easier to connect the sensor to the microcontroller. That meant I had to solder the pins to the sensor, something I had never done before, not even with a single piece of wire. After watching a bunch of YouTube tutorials, I finally gathered enough courage to heat up the soldering iron, pick up a piece of soldering wire, and start connecting the pins. I worked very slowly because I didn't want to make any kind of mess on the sensor that would be hard to clean up later. After the BMP sensor, I started soldering the Pico microcontroller. Attaching pins to the Pico wasn't too hard because it has much larger gold pads for soldering compared to the BMP sensor. Although it was my first time doing that, I think I did a decent job. Not perfect, but not bad either. A few joints were a little messy, but everything worked fine in the end. Before testing the Pico, I had to install MicroPython on it. Then, I started with a basic LED toggle code. This code simply turns the onboard LED on and off. Just to be clear, I used ChatGPT to generate all the code you'll see in this video. Coding, like soldering, is a completely new experience for me. But there's a thought I really want to share. A few years ago, skills like coding were difficult to learn. People had to study at universities and spend a lot of time and money. But today, almost anyone can start coding using AI tools like ChatGPT. Just like me, I have no prior experience, yet here I am, coding a microcontroller. It's very basic, but to me it still feels like an advanced achievement. As you can see, the onboard LED is blinking. I can even change its speed to my liking. A flight computer's main job is to measure altitude. To do that, I connected the altitude sensor to the microcontroller using some female-to-female jumper wires. The wiring wasn't too complicated. I followed some instructions I found online, and the BMP sensor was ready to be tested. First, I uploaded a test code to the Pico that would read data from the BMP sensor and display the altitude. After that, I wrote the main code to start actual measurements. But as soon as I hit run, I got this. I saw this error a few times, and then suddenly, I started getting some really strange readings. Well, it's 33 degrees Celsius here, not minus 40. And I'm just 4 meters above the ground, not 32,000 meters. Maybe the sensor's broken because I dropped it so many times. After trying several times, I still couldn't get any accurate readings, but I'd already prepared for this problem. If you comrades watched my unboxing video, you might remember that I had also bought a backup altitude sensor. So I took the new sensor, soldered it, and replaced the old, drunken BMP-280. And guess what? It worked. Although it was still a little off at first, it started measuring correctly after some code calibration. After that, I saved a simple program in the Pico that turns on the onboard LED if the sensor detects a height above 3.5 meters. Also, my 3.7-volt lithium polymer battery can be directly connected to the Pico because it has an onboard step-down converter. Now the system starts automatically whenever the Pico powers on. When I went above 3.5 meters, the LED lit up. And it switched off when I came below 3.5 meters. Everything was working well at that point. The altitude sensor is doing its job well, so now we can leave it alone and move on to the MOSFET module. The MOSFET module I have is an IRF520, and its job is to trigger the pyro charges to deploy the parachute. To test it, I connected everything together. This time, the wiring was a bit more complicated, so it took a while. I first connected a small RC helicopter motor as a load, and it worked fine. The MOSFET module did exactly what it was supposed to. To simulate an E-match, I replaced the motor with a small bulb, since I used to make igniters using these types of bulbs. However, when I tried running the MOSFET again, it didn't work. I double-checked the wiring, tried different code, and repeated the process several times, but nothing worked. When I asked ChatGPT about the issue, it explained that the MOSFET I was using is not a logic-level MOSFET. That means it doesn't work properly with the Raspberry Pi Pico's 3.3V output. ChatGPT suggested using a transistor and a few resistors as a workaround, but I didn't have those components at the time. It also recommended buying a proper 3.3-volt logic-level MOSFET instead. So now I have to replace my MOSFET module and get the necessary resistors. As I'm editing this video, I've already placed an order for those parts. Once I receive the parts, I'll build the flight computer on a perf board and then start uploading videos about the model rocket build. If you've watched this far, thank you for your support, comrade. I'll see you in my next video.